Hey guys, it's Monday, March 4th. It's currently Monday for me too. It's 6:30, so I'm cutting it pretty close, but no punishment. I was hanging out with some of my girlfriend's friends whom I've never met, but they brought up how they saw that video of me on Facebook singing "Call Me Maybe," so I'm gonna try to keep the punishments to a minimum this time around. So today I want to talk about space. I think I have a lot to say, so I'm going to jump right in, but I actually have no idea what's going to happen. I don't know a lot about space or physics. I took like Physics 101 last semester, and now I think I'm a physicist. But I like to look at this stuff anyway. It's really cool, and I think it's amazing, like what kind of weird stuff happens in space. Before we really knew a lot about space, we knew the crazy stuff would happen thanks to Einstein. He did a lot of work with light, and how light interacts with its world, and it's really amazing. He was able to predict what would happen when light went into a supermassive black hole without even really knowing that those kind of things really existed. He just, based on his observations around the planet Earth and how light behaved here, he was like, yeah, it probably would happen this way if there was, he said if there was a star big enough, it could probably suck the light back into itself. As it was so massive, so much gravity. And he was right, that kind of thing exists in real life. It's so crazy. He did it based on all observations and experimentation on Earth. I think that's amazing. But anyway, it's cool. It's weird because it kind of makes sense, I think, to some degree that stuff orbits bigger stuff with gravity. I mean, whatever gravity is. Because it has mass, and it's kind of like a marble rolling around on a bent piece of paper. We've all seen that, of the picture of space-time where it's like a ball sitting on a weird plane with lines going across it, and you're like, oh yeah, the ball would roll around in like a spiral. Right? That makes sense. However, light does not have mass. It just has energy and momentum, which is all it takes to be affected by gravity. And that makes gravity really hard to understand. It is a bend in the four-dimensional space-time thing that we live in, and it's really easy to see bends in two-dimensional planes because they go straight down, but think about a bend in three dimensions plus time to make four dimensions. I can't even really explain to you what that is. No one really can draw a picture of it, but it happens with objects in space, and it has weird effects on light, since light can be actually affected by this bend, since you see light has this property where it travels from point A to point B as fast as possible. If that point, the distance is warped, like a weird warp, a bend, we don't see the bend in space because it's nothing. There's nothing out there to see, but light travels along that bend, so it looks weird. It's called gravitational lensing. And if you look at like a galaxy with a black hole between you and the galaxy won't look like a normal spiral galaxy. It'll be like a weird smudged thing of light. You can actually see pictures of galaxies being smudged by black holes, because we've never actually seen what a black hole looks like. We don't have a really good photographer, and we just see the effects. It's really neat. Also, speaking of black holes, man, they have a lot of gravity, so much that photons, which are those little particles with momentum and energy, get sucked in. And they don't really get sucked in the sense where like the black hole is like pulling them towards them. They're just like such a deep compression in the space-time fabric that the light falls in and just never comes back out on the other side. So that's where no one knows what's down there, like where they go, but that's what happens. However, just like planets are orbiting the sun and our moon's orbiting Earth, light can orbit a black hole. There's a point where the momentum the light has is just enough to like make a perfect, I guess you'd say it's like a pull, like the black hole's pulling the light down and the momentum is wanting it to go this way. So the light kind of cancels out that movement into a circle forever. That's called the photon sphere. It's just a bunch of photons orbiting a black hole. Can you imagine what it'd be like to look if you were in the photon sphere? Like you look to the side, you would see light reflecting off the back of your head, rotating around the black hole, coming back to your eyes. What would that be like? I don't even know, man. That's just not able to conceptualize that. There's also a thing called event horizon. So if you're outside the gravity of a black hole and you watch something go into a black hole, you would see it slowly approach the black hole, and then it would stop moving and just fade away into nothing. It would not go into the black hole, because by the time it gets into the black hole, any light that's reflecting off it is not coming out of the black hole. It's going also down into that depression in space-time. So you would just see stuff fade away before your eyes. It's because the photons get lost in the photon sphere. That's why it fades out. It wouldn't just disappear either. It's just so weird. And the cool thing is, Einstein knew about all this before scientists were able to see it and do experiments about it to prove it was right. He just guessed it would probably be right based on how photons behave on Earth. That is amazing. Anyway, I'll see you next Monday. Have a great week. Take care, guys.